Hello everyone, welcome to CodersCamp. So today we are going to cover maximum frequency stack. The input given is the operations need to be performed in frequency stack and we have to return the output of the performed operations. So now here the frequency stack can perform two operations, push and pop. Push is similar to what we perform in a normal stack, which is pushes an integer to a stack. So here pop removes and returns the most frequent element in stack. If there is a tie for the most frequent element, the element closest to the top of the stack is removed and returned. So let's understand this with an example. So now here is a given example. Let's first create our frequency stack. So now we start pushing our element 5 first, and then 7 and 5 again, and one more 7. Let's continue here, and 4 and then a 5. Then starts the pop operations. So now in normal stack we will be removing or popping the topmost element from stack. But here in this frequency stack we have to remove the most frequent element. What is the most frequent element? If you see, we have 3 5s, 2 7s and 1 4. In this case the most frequent element is 5. So we have to remove 5 and it happened to be the topmost element also is a 5, but we have to remove which is the most frequent element in the stack. The most frequent is 5, so we are removing 5. Now 5 is removed from the stack. So now let's update 5 to 2 because we have only 2 5s left after removing 5 from the stack. So now again one more pop operation. In this case you have to remove the most frequent element. Here if you see we have 2 5s and 2 7s. In this case they both are most frequent. The other condition given in the problem statement is if two elements get a tie, then the number or element which is near to the top element is going to be popped. That is, if you see the top element in the stack is 4, the next top is 7. So out of 5 and 7, 7 is the most recent to the top. So we are going to remove 7 from the stack. So now we have only 1 7 left in our stack. Again another pop operation. So in this case you have to check the most recent or frequent element. The most frequent element is going to be 5 again. So we are going to pop 5. So now 5 becomes only 1 in the stack. Moving on to one more pop. Here if you check, all elements are of equal frequency. That is 5 is 1, 7 is 1 and 4 is 1. In this case we have to remove the recent one to the top. So here recent one to the top or the topmost element is 4. So we are going to pop 4 from the stack. So our operations are ended. Now we have left with 5 and 7 in our frequency stack and we have to return it. So this is how our frequency stack works. So how are we going to approach this? So now our stack is going to pop the elements based on two conditions or two factors. One, we have to check whether it is most frequent element. If not, if many elements or two elements having the same frequency, in that case we have to check which is the most recent to the top element. So we need for a number x its frequency as a factor and the index. Y index, we have to find whether it is close to the top or not. So we need two factors for a given number x. So in this case we are going to maintain a priority queue. Why priority queue? Because we have to take the elements based on the factors. So we need to order the elements getting inserted to a stack based on the factors given. So we are going to use priority queue and sort them or push them into the priority queue based on the factors. So now our priority queue is going to have an integer array. That integer array is going to have the element or the number going to push into a stack and its frequency and then the index it has entered the stack, because by using that we can calculate how far it is or how near it is from the topmost element. So now first our example is gonna have insert 5. So here 5 is the value and its frequency is 1 and its index is also 1. So now the second element is going to be inserted is 7. 7 is going to be 7 and frequency is 1 and it is entering as the second element. In this case, our priority queue has to arrange based on the index, because our stack will be having the first element at the bottom and the recent element inserted at the top. Same way, we are going to arrange our priority queue based on the index it is getting inserted. So we are going to sort it based on the index first. So let's have our priority queue. Now our priority queue will have 7 first because it is the topmost element according to the stack or the element recently inserted. So we are going to put 7 first and then 5. We are going to use or write a comparator that actually sort our input in this way. So now we are going to insert 5 again. In this case, our priority queue will have 5. The second element is going to be frequency. Frequency is going to be 2 because we already have a 5 and index is going to be 3. In this case, if you are going to pop an element from the stack, which element will you pop? You will be popping the 5 because 5 appears twice. The most or the more frequent element is going to be popped from the stack. In this case, we need our 5 inserted secondly to the first. How do we do it? We compare the second factor frequency. So we are going to compare the frequencies first. If the frequency is higher, we're going to put that first. If not, if both elements have same frequency, we are going to compare with the index. So our priority queue will have 5, 2, 3 first, and then comes 7, 1, 2, and then comes 5, 1, 1. So to make it clear, we are going to put an integer array to our priority queue. So that integer array is going to have 3 factors, that is the given number and its frequency and in which index it is inserted into the queue. So based on the frequency first, we are going to compare the frequencies. Whichever is having the higher frequency is going to be ordered first, because we are going to pop the first element present in the queue, so that we are going to arrange it based on the frequency. If two numbers having the same frequency, in that case we are going to consider our third factor index, and whichever is having the higher index we're going to put that next. Why? Because that will be close to the top element in the given stack. By arranging this way, we are going to put all our element into the priority queue, so that the first element we're gonna pop is going to be the first element in the queue. So let's see how are we going to code it. So as I said, I'm gonna have a priority queue. Which is going to hold an integer array with the 3 factors. And I said we are going to calculate the frequency or keep track of the frequency of the elements inserted. To keep track of frequencies, I'm going to get the help of my math. So inside frequency stack, I'm going to have my data structures declared. So inside that, we are going to write a comparator which compares the value which actually first compares with based on the frequencies. That is, we are going to check if my frequencies are equal. If they are equal, then sort it based on the third factor, that is index at which it is inserted into the stack. So we have to put that in ascending order. If not, if the frequencies are not equal, then we are going to sort it based on the frequencies itself. So simply it compares the frequencies first. If the frequencies doesn't match, frequencies are in index 1. So it compares the frequencies. If frequencies matches, then we are going to sort it based on the index. If not, we are going to sort it based on the frequencies. So it makes it easy. Now in push operation, we are going to first record the frequency into our map. So we record the frequencies because we are going to add it to our priority queue. So before adding to queue, we are going to record the frequency. Now inside that, we are going to put our element and its frequency from the map. And we're gonna have one more factor, index. So we're gonna put the index in which the element is inserted. So finally, we got a frequency, we got our array. We are simply going to push that to our priority queue. So we simply pushed it into our stack. Now pop operation. To pop operation, we know the first element from the queue is going to be the element which has to be popped. So simply we are going to remove the topmost element in our queue. So before removing, we have to update our frequency table, because once the number is removed, we have to decrement the occurrence of that x. So we need to know which element is popped. So we are going to take that in an array. So we removed by polling that from our queue. So once we removed, we are going to update that to our map. So finally, we return if a is equal to null, which means we don't have any element to pop from the queue, then return -1. If not, return the element. So yes, simple. We just constructed our priority queue to sort it based on the frequency of the number. If the frequencies are same, then based on the index. Why index? Because it determines which element is nearer to the top element of the stack. So whenever we push the element, we are updating our frequency table and construct a array, integer array, and push it into our queue. Similarly, whenever we pop an element, we update our map, and then return the variable. Let's run. Yes. Yes, the solution is accepted. So thanks for watching. If you like the video, hit like and subscribe. Thank you.